Okay, so for the combined gas law that you looked at the last video, that is for changing conditions. Whenever you have changing conditions, like you heat up a gas, you cool down a gas, you expand it, you compress it, stuff changes, you're going to use that. For one set of conditions, when there's only one set of conditions, you are going to use PV equals nRT. The pressure, though, has to be in atmospheres, the volume must be in liters, and as always, temperature must be in Kelvin. If you need to switch from milliliters to liters, keep in mind that 1,000 milliliters are in a liter, and you should have all the conversion factors to get to atmospheres on your formula sheet. N is the number of moles, so again, if you have grams, you're going to have to use the molar mass to get to moles because you need to have that for N. R is what brings it together and makes it equal. This is the universal gas constant, 0.0821. The units are liters atmospheres over moles Kelvin. All of those units go with R. There is a shortcut, but I'm not going to dwell on that because you don't need the shortcut, but you can use it if you're at STP. 1 mole is 22.4 liters, but that's only at STP standard conditions, so remember those. Great, so we're just going to go ahead and do a couple of examples here. Everything is exactly the way I need it. It is one set of conditions. Nothing's changing. It's just here's the sample, here's the temperature, you know, all that good stuff. The pressure is already in atmospheres, so it's like perfect. The volume is 8.56 liters. It's in liters, perfect. We're going to figure out N. R is always 0.0821. Units are liters atmospheres over moles Kelvin. I guess I won't write that all down, but just remember those are the units. And the temperature is 0 degrees Celsius, but of course we have to add 273 to that to be in Kelvin. Calculate that, you should get 0.573 moles. Now, there's also a chance that you won't have everything the way you need it, so 371 torr, you can't use that in PV equals nRT. You're going to have to go to your equalities and see that you can convert this into 0.48 atmospheres. Okay, so make sure you know how to convert. The other thing is you can't use grams, you have to have moles. So you're going to have to take 42 grams of carbon monoxide, and you need to realize that a mole of that is 28 grams. So you are looking at 1.5 moles. Now at this point you're ready to do PV equals nRT. So one set of conditions, we're going to use PV equals nRT. Pressure is going to be 0.48 atmospheres. Volume is what we're looking for. N moles is 1.5 moles. R is always 0.0821. Oops, I'm really dipping in there. And temperature is going to be 25 degrees Celsius, but we have to add 273 to that, so 298 Kelvin. And again, make sure that you can do the math and get 75.2 liters. For this one, it's still same thing, one set of conditions, PV equals nRT. And it asks for how many grams. So what we're first going to do is solve for moles, and then we will convert. We are at standard conditions. Our pressure then, standard pressure is 1 atmosphere. We're told we have 1 liter. We're solving for N. And temperature is standard temperature, STP, standard temp, is 273. So we're going to solve for N, and that should turn out to be 0.4006 moles. And then we're going to convert, and remember that nitrogen is diatomic. It's not going to be 14. It's N2, so not 14, it's 28, and you should get 1.25 grams. Okay, there are other things that you can do using PV equals nRT, so we're going to just take a look at them. We're told that the density of a gas is 0.82 grams per liter, so just keep in mind that that is 0.82 grams per 1 liter. Okay, really important that you see that. The pressure is 600 millimeters of mercury, temperature is 25 degrees Celsius. What is the molar mass? Now keep in mind that the molar mass is how many grams per 1 mole. So we're kind of wondering, hey, how many grams is that? But realize that we actually already have the grams. It's 0.82 grams. The only thing we don't have is this is in liters and we want 1 mole. This is 1 liter, we want 1 mole to answer our question. So this is what we're going to do. Again, we're going to use PV equals nRT for so many things. As long as conditions aren't changing, we're just going to use PV equals nRT. Pressure is 600, but of course I can't use 600. I have to have that in atmospheres. So I'm going to take a little shortcut here and just put 600 divided by 760 because I know that will give me atmospheres. The volume, I think this is the other sticking point for this question, but we're going to go ahead and use 1 liter because we know we want to get that 1 liter into however many moles. We don't know if it's 1 mole. That's what we want, but we're going to see how many moles. R is 0.0821. Temperature is 25, so that's 298 Kelvin. So we're going to get the moles here, and I think that's 0.0323 moles when you calculate that. So the last thing we're going to do is we're going to take that 0.82 grams. So the molar mass is going to be 0.82 grams divided by 0.0323 moles. And so when you take 0.82 and divide it by 0.0323, you should get 25.4 grams per 1 mole. And that's what we want. That is it. Just another one, it's at STP. Because it's at STP, pressure is 1 atmosphere. We're always going to use 1 liter, 0.8021, and standard temperature 273 Kelvin. Our moles are going to be 0.0446 moles. It's always that way when it's at STP. And the last thing we're going to do is we're going to take those grams. We're going to put it over the moles. And we will get a molar mass of 37.4 grams per mole. Okay, so that's how you do that one. We're going to do one more here. Density. The density of CH4 at 300 torr and 100 degrees Celsius. Okay, density. We are looking for grams per 1 liter. That is ultimately what we need, is grams per 1 liter. So what we're going to do here, as I don't have enough room, so I'll do this, is we're going to, again, use PV equals nRT, and we're going to solve for moles. I know that the gas is CH4, so I kind of know what the molar mass is. We're going to go to density, so it's kind of the opposite of the last problem. All right, pressure is 300 torr, but of course, again, I cannot use that. I must have atmospheres, so we have that. Again, we're going to use 1 liter because that's what we want. We want a density. Remember, density is grams per 1 liter, so let's use 1 liter. We don't know the moles. R is always 0.0821, and the temperature is 100 degrees Celsius or 373 Kelvin. So we're going to get the moles. It's going to be 0.0129 moles, and I would always use 2 to 3 sig figs. I've used 3 here. If you want to put 0.013, that's okay, but that's 2 sig figs, so that'd be it. All right, what you're going to have to do now is I need grams. We've already have the 1 liter, we're good there, but I need to get this to grams. So what basically is going to happen is 1 mole is 16 grams. Now where did that 16 come from? Well, 1 carbon is 12, another 4 hydrogens each at 1. That's where the 16 comes from. That's its molar mass. So we're going to take 0.0129 times 16. We're going to get 0.206 grams. Now, that's not the final answer because I need the density, so make sure that you put that over 1 liter. That's the density. Okay? So again, just kind of showing you, again, STP is 1 atmosphere. We always want to use 1 liter. Looking at moles. Well, that was not very neat. Temperature is at standard temperature, 273. You're going to get the moles at 0.0446 moles. Again, that's CH4. So that weighs 16 grams per mole, and we're going to get 0.714 grams. Again, though, that is not your final answer. Put that over 1 liter. That's the density. That's your answer.